Our planet, Earth. A vibrant tapestry of life, teeming with diverse ecosystems and crowned by the ingenuity of humankind. But this familiar world we call home is but a single frame in an epic saga spanning billions of years. Today, we embark on a journey through time, peeling back layers of history to reach a period unimaginably distant. Earth, 2 billion years ago. Imagine a world utterly alien to our senses. A world where the very air we breathe would be toxic, the landscape barren and strange. The continents themselves locked in a dance of formation and reformation. This was Earth during the Paleoproterozoic era, a time of immense geological upheaval and the dawn of complex life. Our journey takes us back to a time when the sun shone dimmer. The moon hung closer in the sky and the continents, far from their present forms, were scattered across the globe. This was a time before the dinosaurs, before the rise of animals, even before plants had begun to clothe the land in green. Join me then as we venture into this alien yet familiar world, a world both hostile and teeming with the potential for life as we know it. Our first encounter with this ancient Earth would be a harsh reminder of its alien nature. The atmosphere, far from the life-giving mix we breathe today, was a toxic cocktail of methane, ammonia, and carbon dioxide. Oxygen, so crucial to our existence, was scarce, a mere byproduct of the few primitive life forms that had begun to emerge. Stepping out onto this primeval Earth, we would find ourselves gasping for breath, our lungs struggling to cope with the alien atmosphere. The skies, too, would be unfamiliar. With a thicker, hazier atmosphere, the sun would appear as a dim, reddish orb, casting long shadows across the desolate landscape. This lack of oxygen had a profound impact on the Earth's appearance. Without oxygen to scatter sunlight and create the familiar blue hues we see today, the sky would have been a dull reddish-orange, perhaps even tinged with green due to the presence of methane. This was not a world for humans, or indeed for any air-breathing life as we know it. Yet even in this harsh environment, life had found a foothold, clinging tenaciously to a young and volatile planet. Deprived of oxygen, the land itself would be a stark contrast to the verdant landscapes we know today. Without plants to anchor soil or paint the scenery with vibrant hues, the Earth would be a canvas of browns, greys, and rusty reds. This distinctive coloration was due to the presence of iron oxide or rust, which formed as iron in the exposed rocks reacted with the scarce oxygen. The continents themselves, still in their infancy, were vastly different from their present forms. The familiar shapes of North America, Eurasia, and Africa were yet to exist. Instead, smaller, fragmented land masses known as cratons dotted the globe, constantly colliding and fusing in a slow, relentless dance of plate tectonics. Erosion, driven by wind and rain, would have been a powerful force on this ancient Earth, carving deep canyons into the exposed rock and grinding mountains down to dust. Without the stabilizing presence of plant life, the landscape would have been in a constant state of flux, reshaped by the relentless forces of nature. This was a world of stark beauty, a testament to the raw power of geological processes and the enduring nature of life itself. Despite the harsh conditions, life had already taken hold on Earth. In the shallow seas that covered much of the planet, single-celled organisms thrived, their simple forms flourishing in the warm, nutrient-rich waters. These were not the complex plants and animals we know today, but rather bacteria and archaea, some of the most ancient forms of life on our planet. These early life forms were incredibly diverse, each adapted to survive in specific environments. Some, like cyanobacteria, possessed the remarkable ability to photosynthesize, using sunlight to convert carbon dioxide and water into energy, and releasing oxygen as a byproduct. Though primitive, these early microorganisms played a crucial role in shaping the Earth's future. Their photosynthetic activity gradually increased the oxygen levels in the atmosphere, paving the way for the evolution of more complex oxygen-breathing life forms millions of years later. The Earth 2 billion years ago was a geologically active place. Volcanoes, far more numerous and violent than their modern counterparts, erupted with terrifying regularity, spewing lava, ash, and gases into the atmosphere. These eruptions played a crucial role in shaping the planet's surface, creating new landmasses and releasing gases that contributed to the early atmosphere. These volcanic events, while destructive, were also a source of life. The heat from volcanic vents provided energy for chemosynthetic organisms, which thrived in the absence of sunlight. These life forms, clustered around underwater hydrothermal vents, formed the basis of unique ecosystems that exist to this day. The very air we breathe today owes its existence to these ancient volcanoes. The gases they released over millions of years transformed the Earth's atmosphere, eventually leading to the oxygen-rich environment that supports life as we know it. 2 billion years ago, the Earth's continents were locked in a slow, inexorable dance of plate tectonics. Driven by the immense heat within the Earth's core, these massive plates collided, pulled apart, and slid past one another, constantly reshaping the planet's surface. The continents we know today were still in their infancy, fragmented into smaller landmasses scattered across the globe. Over millions of years, these cratons would collide and fuse, eventually forming the supercontinent cycles that have shaped Earth's history. This constant tectonic activity had a profound impact on life. The formation of mountain ranges, the opening and closing of ocean basins, and the shifting of continents all influenced the evolution of life, driving diversification and adaptation on a global scale. Our journey to Earth 2 billion years ago reveals a planet both alien and familiar, though the landscape, atmosphere, and even the color of the sky were vastly different. The fundamental processes that shaped our planet, plate tectonics, volcanic activity, and the evolution of life, were already in motion. This early Earth, though seemingly distant, is intimately connected to our present. It was during this period that the stage was set for the evolution of more complex life, eventually leading to the emergence of plants, animals, and ultimately ourselves. By studying these ancient environments, we gain a deeper understanding of our planet's history and the intricate web of life that has existed for billions of years. The echoes of this distant past are all around us, etched in the rocks, the air we breathe, and even in the very cells of our bodies.